We shall try our next question. That could be distinguished between causal and non-causal systems with suitable examples. This is a very direct question and easy to answer. But you have to be very careful about the question because the question is about causal and non-causal systems and not signals. There could be another question to distinguish between causal and non-causal signals. But this is about systems. So the answer should contain the following points. The first point is the essence of the answer, which says a causal system is a system whose impulse response, we denote it as h of n, whose impulse response will not contain any samples for negative time axis. Okay, so causal system is a system whose impulse response is 0 for a negative time. Okay, this is for a discrete time case. And in the case of continuous time signals, continuous time systems, a causal system is a system whose impulse response h of t is 0 for all negative time values. Okay, for example, I can draw like this. This is h of t for t. So for a causal system, the impulse response should be like this. It should not contain any amplitudes. So that is, the amplitude should be 0 for negative time axis. Such systems are causal. And if the impulse response is like this, if this is h of t like this, now this impulse response have amplitudes for negative t axis, so the system is non-causal. Okay, so this is the essence of the answer. And now another point I could say is causal systems are practical. Causal systems are always practical, but non-causal systems are not practical. This cannot be practically realized, non-causal systems. All right. Then another point that you can answer is output of the causal system will be containing future values of the input. That means y of t can be a function of x of t plus 1. Right? If this is the input-output relation of a system, then you can definitely say that the system is non-causal, because here the input contains a future value x of t plus 1. All right. Similarly, for discrete time systems, y of n is equal to x of n minus 1 plus x of n. Up to this is a causal system, no doubt, because the output depends on present input, delayed input, previous input, no problem. But if you add x of n plus 1 or n plus 2 here, now this becomes a problem. This is a future value, x of n plus 2 or x of n plus 1. These are all future values. So the present output depends on a future input, an input which is not yet occurred. That is non-practical. So these are non-causal systems. Okay. A very simple example is a switch, right? When you switch on a bulb in your room at t equal to 0, the bulb glows. If this is the bulb glows when you give the input of t equal to 0. That is a causal system, no problem, right? But if you switch on the bulb and the bulb glows even before you switch it on, before you switching on the bulb glows. What does that mean? It's like a ghost in your room, right? That is not practical. I swear ghost stories are all fake lie, right? These are non-practical. Okay, so causal systems are systems where the output never depends on future values of the input. Okay, so that explains this question neatly. Now let us try this question. Find the even and odd components of the following signal. First question is e raised to jt. Okay, then if we are given a signal which is neither even nor odd, or even or odd, whatever, the method to find out the even component xe of t is equal to the given signal x of t plus its reflection x of minus t whole divided by 2. This is how you find out the even component of a signal. And similarly, the odd component of that signal is x of t minus x of minus t whole divided by 2. So you need to be very thorough with these results, and it will be very simple if you are thorough with this result. Okay, and now let's find the first problem. A, given x of t is equal to e raised to j into t. So what is x of minus t? You replace t with minus t, so e raised to minus jt is x of minus t. Now what is xe of t from this equation? Xe of t is equal to x of t, which is e raised to jt, plus x of minus t, which is e raised to minus jt whole divided by 2. And if you are thorough with the result, you have very important two results here. What is e to the power jt? That is cos t plus j sin t, right? And what is e raised to minus jt? That is cos of minus t, which is cos of t, plus j sin of minus t becomes minus j sin t. So you should be thorough with these two results also. These results are very much needed in many problems that you would come across in this course. So out of these results, what is e raised to jt plus e raised to minus jt by 2? If you add these two equations, what you will get is 2 cos t. Okay, and when you divide by 2, here is a divide by 2 there, so that 2 will get cancelled. So the answer is cos t. Okay, so the even part of e raised to jt is cos t. Now what is odd part? Xo of t. Xo of t will be equal to, you take this equation, x of t minus x of minus t by 2. So e raised to jt minus e raised to minus jt whole divided by 2. Again, you have to look at these two equations. When you find e raised to jt minus e raised to minus jt, you will get 2j sin t, and divide by 2 will give you just j into sin t. Okay, so the answer is j into sin t. Okay, now let us answer question B, where x of t is given to you as cos t plus sin t plus cos t sin t. Okay, so first of all, you have to find out x of minus t, then only you can apply these two equations. So x of minus t is cos of minus t plus sin of minus t plus cos of minus t into sin of minus t. And you know the trigonometric relations, where cos of minus t is equal to cos of t and sin of minus t will be equal to minus sin t. So applying this, you will get ultimately x of minus t as cos t minus sin t, and here it is minus sin t cos t. So this is x of minus t, and this was x of t. Therefore, xe of t, we can apply this equation. Xe of t will be equal to, you have to add x of t and x of minus t, then whole divided by 2. So cos t plus sin t plus sin t cos t, that is our x of t. Now we have to add this equation also, plus cos t minus sin t minus sin t cos t. Never stop here, we have to divide whole by 2. So what we will get is, we have a sin t and sin t to cancel. This term also get cancelled with that. So what you will get is 2 cos t by 2, which is equal to cos t. So the even part of the signal is just cos t. Okay, and now we will find out the odd part. Okay, now what is odd part? Xo of t is equal to, we have x of t here and x of minus t here. So x of t minus x of minus t by 2. Okay, So x of t is cos t plus sin t plus sin t cos t minus of, what is x of minus t? It is cos t minus sin t cos t whole divided by 2 here. And you can cancel cos t and cos t here, then nothing else. Okay, so what you will get is here has sin t minus and minus equals plus, so 2 sin t, similarly 2 sin t cos t whole divided by 2. That will give you the answer as sin t plus sin t into cos t, or you can simplify as a sin t into 1 plus cos t. You can further simplify it, or you can stop here. So this is the answer for xo of t. Alright, the next question is to observe the given signal and sketch the following y of n and z of n. Question two questions. And you are given x of n. So here x of n is a discrete time signal. So before proceeding to the solution, let me remind you that whenever a non-integer value comes for n in discrete time signal, you just neglect that sample. If n is non-integer. So what I mean is, in a discrete time signal, only integer values comes as n values. Okay, only integer. Fine. So let us move on to this question. The first question is to plot this signal 2x of minus 2n plus 1. So definitely there is a shifting and scaling, right? So what we do is we go for the precedence rule. And as per precedence rule, first you do shifting, then only scaling. Okay. So we are given x of n in the question. So to find out 2x of minus 2n plus 1, first what you have to do is, from x of n you find x of n plus 1. That is what precedence rule says. So let me draw x of n plus 1. So x of n plus 1 should be x of n but shifted by 1 unit to the left. So this sample at n equal to 0 comes at n equal to minus 1. So amplitude 2 at n equal to minus 1. The next is amplitude 1, that should be at 0. Then 2, 1, 1, and 3. The last sample is from the question should be 3. Okay. So the sample is 2. This is 1, 2, 1, 1, and 3. So this is x of n plus 1. Now what we have to do next is, you have to find from x of n plus 1, you have to find x of 2n plus 1. Let me remind you, if you are well experienced in doing the problems, you can directly find out x of minus 2n plus 1. But for the time being, let me make it simpler by finding x of 2n plus 1. So what is x of 2n plus 1? This is x of n plus 1 scaled by 2. Okay. Okay, so I'm going to draw to x of 2n plus 1. What is x of 2n plus 1? X of 2n plus 1 is the scaled version, right? We are scaling by 2, so the signal should be compressed. So the amplitude at n equal to minus 1, that is amplitude 2, this sample as such should be occurring at minus 1 by 2 here, at minus 1 by 2. But is that possible? No, as I've already told you, in discrete time signal, if your n is not an integer, then neglect that sample. Okay, so as per our theory, sample at minus 1 should be occurring at minus 1 by 2, but minus 1 by 2 is not an integer, so we have to neglect this sample. You no need to draw this sample, that is gone. Okay. Now the sample at n equal to 0, where should it come? It should come at 0 divided by 2, that is 0. So the sample 1 is at 0 itself. So we can draw sample 1 at 0 itself. Okay. And next is sample at n equal to 1. Where should it go? Because scaling factor is 2, sample as such at n equal to 1 should go to n equal to 1 by 2 here. But again, n equal to 1 by 2 is not possible, so you neglect this sample also. Okay. Now what is the plight of sample at n equal to 2? Sample at n equal to 2 goes at 2 divided by 2 here, that is 1. So this sample goes to here, 2 by 2, 1. Let's do that. The amplitude of that sample is 1. Okay. So the amplitude of that sample is 1. Sample at n equal to 2 comes to n equal to 1. Now what about this sample? Again, 3 divided by 2, 1.5 is not an integer, so you have to neglect this sample. Now take this sample, 4 divided by 2. So this sample goes to 2 as such. So the amplitude is 3. So amplitude 3. Let me write the amplitudes also. 1, 1 and 3. So this is x of 2n plus 1. And finally, our question is to find out x of minus 2n plus 1. Not finally, we have to find it twice of this also. Anyway, we will find out x of minus 2n plus 1. We have x of 2n plus 1 here. What is x of minus 2n plus 1? You just flip the signal about the y-axis. Okay, flip the signal about the y-axis. Now what happens when you flip this signal here? The sample at n equal to 0 remains there itself because it is at y-axis. So this sample comes at n equal to 0. Now what happens to this sample? This sample goes to minus 1. Okay, so this sample goes to minus 1 and this sample goes to minus 2. So this is how you flip the signal or reflect the signal. The operation is called a reflection, time reflection. So you have to flip the signal about the y-axis and you will get this. So amplitude 3 is at minus 2, amplitude 1 is at minus 1 and this one is at 0. This is x of minus 2n plus 1. And finally, what we have to obtain at the question is 2 times x of minus 2n plus 1. This 2 times is an amplitude operation. So what we have to do is you double all the samples in x of 2n plus 1. I mean x of minus 2n plus 1 to get to x of minus 2n plus 1. Okay, when we find out the twice of the signal, you will get amplitude or sample value as 2 in n equals 0. Again 2 at n equal to minus 1 and 6 at n equal to minus 2. Okay, this is very simple. We are just doubling these samples, which is because it is an amplitude operation. Sorry, this is 2 and here it's also 2. So this is the final answer to be obtained for question A. Now let us do question B. We have to find z of n is minus x of n by 2 minus 2. Clearly here also, first we have to find out x of n minus 2 as per precedence rule. Shifting should be first. Then we have to find out x of n by 2 minus 2. Here the scaling factor is 1 by 2. And then we have to find the amplitude operation minus x of n by 2 minus 2. Okay. So initially what I'm going to draw is x of n minus 2 from x of n. X of n is given here. So we have to find out x of n minus 2. Okay, I am going to draw x of n minus 2. N minus 2 is, x of n minus 2 is nothing but shifting x of n by 2 units to the right. So first sample, this first sample will be coming at 2 units shifted, that means at n equal to 2 and so on. So starting sample at n equal to, at 2 will be at n equal to 2. Then sample 1 then again sample 2, sample 2 at 4, then sample 1, again sample 1, and final sample is at n equal to 7, which has an amplitude 3. Okay, so this is x of n minus 2. My next aim will be finding x of n by 2 minus 2. Remember that the scaling factor is 1 by 2 here. So we have to multiply, we have to divide every time instant with 1 by 2 to get the corresponding sample in x of n by 2 minus 2. Okay. Now let us attempt to draw x of n by 2 minus 2. So look at the first sample, it is at n equal to 2. So where should it come at x of n by 2 minus 2? You divide 2 with the scaling factor. Okay, the scaling factor a is 1 by 2. So if you divide 2 with the 1 by 2, you will get as 4. So what I'm saying is this sample should come at 4 in the signal. Okay, so I'm drawing this sample to n equal to 4 here. So amplitude 2 is at n equal to 4. Okay, now what about this sample? This sample is at n equal to 3. So it should be at 3 by 1 by 2, which is 6 here. Okay, so sample 1 is at 6. Now next is this sample at 4, that should be at 8. So sample with amplitude 2 is at 8. Now this sample is at 5, so it goes to 10. So the amplitude 1 is at 10. Now this sample is at 6, which should be at 12 in the signal, and the final sample is at n equal to 7 here. So 7 by 1 by 2 is 14. So the sample with amplitude 3 is at n equal to 14. Okay, so this is our x of n by 2 minus 2. Is our answer final? No, because we have to find out x of minus of x of n by 2 minus 2. Now this is very simple. This is a simple mathematical amplitude operation. You have to invert all these samples. You have to invert all these samples or multiply it with minus 1, whatever it is. The final answer you will get is our minus x of n by 2 minus 2. Okay, let us attempt to draw minus x of n by 2 minus 2. Just very simple. We have to invert all the sample. So this is minus 2. This is minus 1. Again minus 2, minus 1, minus 1, and minus 3. I need to write down the sample values. This is minus 2. This is minus 1. Minus 2, minus 1, minus 1, and minus 3. I have forgotten to do it here. Okay, so this signal is an inverse of this signal. Okay, so this should be our final answer. Alright, let us start with the next question. Compute the power and energy of the following signals and check whether they are power signals or energy signals. The first question among this is x of n equal to 1 by 3 raised to n u of n. Okay, so the first question is x of n equal to 1 by 3 to the power n u of n. On a single look, it is clear that the signal is a non-periodic signal. So it could be an energy signal. And let us start with finding the energy of the signal, which is given by E equal to sigma over n equal to minus infinity to plus infinity mod x of n square. A modulus is meaningless here because this is a real signal, and this equation now reduces to sigma over, and you don't need to summate it from minus infinity to plus infinity because the signal is getting multiplied by u of n here, and therefore the signal exists only from n equal to 0 to infinity. So summate n equal to 0 to infinity instead of minus infinity to infinity. And what is x of n square? It is 1 by 3 raised to 2n. Okay. Now we need to expand this summation. Putting n equal to 0, you get 1 by 3 raised to 0, just 1. Plus, for n equal to 1, you get 1 by 3 raised to 2. For n equal to 2, you get 1 by 3 raised to 4, plus etc. and goes to infinity. Okay. And definitely, this is a geometric progression. This is an infinite geometric progression whose sum is, we already know it is a by 1 minus r, where a is the first term and r is the common ratio. But you should be careful about this equation, because this equation can be applied only when the common ratio mod r should be less than 1. Only in this case we can use this equation. And checking this condition is whether it is valid here. Here r is equal to 1 by 3 square. Okay, this 1 by 9 is definitely less than 1. So we can definitely use this equation here. Okay, so applying that equation, you will get the sum as first term. A is first term, so 1 by 1 minus r is 1 by 9. Okay, so the answer will be 9 by 8. So 9 by 8 is the energy of the signal, which is a finite value. Okay, so that is the energy of the signal. Now, similarly, you can find the power of this signal. Now, in applying the expression for power, you should be careful that this equation is a non-periodic signal. So power, average power of a non-periodic signal is given by limit n tend to infinity 1 by 2n plus 1. Okay, sigma n equal to minus n to plus n x square of n, mod x square of n, or x square of n. Okay, so that comes to be limit n tends to infinity 1 by 2n plus 1. Sigma, you need not find the sigma all the way from minus n to plus n, because it is getting multiplied by u of n. So n equal to 0 to n x square of n. X square of n is 1 by 3 square raised to n. So it is, I can write it as 1 by 9 to the power n. Okay, so that is equal to limit n tends to infinity 1 by 2n plus 1 into putting n equal to 0, you will get 1 plus 1 by 9 plus 1 by 9 square plus etc. Is it an infinite GP? No, this is not an infinite GP, because the summation is from n equal to 0 to n equal to plus n. Okay, n equal to plus n. So what is the last term? 1 by n raised to capital N. Okay, so this is a GP, but it is a finite GP. Okay, finite GP. What is the sum of a finite GP? Sum of a finite GP is equal to Sn equal to a into 1 minus r raised to n by 1 minus r, where a is the first term and r is the common ratio. And what is n here? N is the total number of terms. Okay, let us come back to the equation. So this is equal to limit n tends to infinity 1 by 2n plus 1 into, what is the sum of this finite GP? A, first term is a, 1 into 1 minus, what is common ratio? Common ratio is 1 by n, 1 by 9, right? 1 by 9 to the power, what total number of terms? N is total number of terms. How many terms are there? It is not n, but it is n plus 1 terms. We have n plus 1 terms here, because it is starting from here it is 1, 2, 3, etc. up to n, but there is one more term here, 4 by n raised to 0. So n plus 1 terms. So n plus 1 whole divided by 1 minus r, 1 minus 1 by n. Okay, so whatever be this, the answer will be 0, because whatever be this in this bracket will be a finite number, but we are doing a limit n tend to infinity 1 by 2n plus 1 will give you a value tending to 0. Okay, so what we have informed from this problem is energy is a finite value, 9 by 8 is a finite value, and the power is 0. So the signal is an energy signal. This is the final inference from this question. Okay. And now we'll proceed with the question B. Y of t equal to 1 plus e raised to minus 5t into u of t. This signal can be a power or energy signal. We cannot be sure of it by just observing the signal. So we just find out energy and power. First we will find out the power of the signal. This signal is definitely a non-periodic signal. So let us calculate power as limit t tends to infinity 1 by t integral. Actually the equation is minus t by 2 to plus t by 2, but the signal is being multiplied by u of t. That means the signal extends only in the positive t axis. So we can let the limits as 0 to t. 0 to t x of t square dt. Right. So that comes to be limit t tends to infinity 1 by t integral over 0 to t. What is x of t square? X of t square is 1 square plus e raised to minus 5t the whole square. Let me write it as e raised to minus 10t plus 2 into 1 into e raised to minus 5t dt. Okay, I've done it in a single step. I hope you can follow it. So that becomes limit t tends to infinity 1 by t into what is integral 1? It is t. What is integral e raised to minus 10t? It is minus 1 by 10 e raised to minus 10t. And what is integral of 2 e raised to minus 5t? It is minus 2 by 5 e raised to minus 5t within the limits 0 to capital T. Now this is limit t tending to infinity 1 by t. Applying the limits, you can see that it is t minus e raised to minus 10t by 10 minus 2 by 5 e raised to minus 5 capital T. Okay, minus 0. Okay, then applying lower limit in this term, you will get it as plus 1 by 10 and plus 2 by 5. Okay, because e raised to 0 is 1. Now let us see this as limit t tending to infinity 1 by 10 into t minus e raised to minus 10t by 10 minus 2 by 5 e raised to minus 5t. What is the value? This is equal to 5 by 10. It is 1 by 2 plus 1 by 2. Okay. So that becomes limit t tending to infinity. I can take this 1 by t into the bracket. So becomes 1 minus e raised to minus 10t by 10t minus 2 by 5t e raised to minus 5t plus 1 by 2t. Okay. Now from this equation, limit t is tending to infinity. So limit 1 by t will tends to 0, right? So we can write it as limit 1 by t tending to 0, 1 minus e raised to minus 10t by 10t minus 2 by 5 e raised to minus 5t by t plus 1 by 2t. So all terms except this term will be having a 1 by t factor, right? All those will be 0. So the answer is 1. 1 minus 0 plus 0 will give you 1. Okay. So the power is equal to 1 watt, which is finite. Okay. So we played around the power of this signal first and obtained it as a finite value. Now let us see what is the energy of this signal. Okay, energy of this signal is given by integral over 0 to infinity. And you not need to integrate from minus infinity to plus infinity because the signal is multiplied by u of t. So the integral is from 0 to infinity x of t square, which is equal to integral 0 to infinity 1 plus e raised to minus 10t plus 2 e raised to minus 5t dt. Okay, and you not need to expand it because this integral from 0 to infinity will always give you an unbounded output. Okay, so because integrating this term alone gives you infinity, so no need to take care of these two terms. The answer will be infinity. Okay, so what we have finally obtained is power is equal to 1 watt, which is a finite value, and energy is tending to infinity. Therefore, the signal is a power signal as per our definitions. Okay. All right, and the next question is define, sketch, and list the properties of continuous time impulse function. So the question is to define, then sketch, and list the properties of what? Continuous time impulse function. It is not discrete time, continuous time impulse signal. Okay, so let us start with the definition. The definition of impulse signal is very important. So impulse signal, continuous time impulse signal is defined as del of t is equal to 0 for t not equal to 0. Okay, and del of t is not equal to 0 at t equal to 0. Right, these are two conditions for an impulse signal. So an impulse signal, del of t equal to 0 for t not equal to 0, and del of t is not equal to 0 at t equal to 0. Right. Before sketching the signal, let me remind you that many textbooks, you can see many textbooks where it is given as del of t is defined as infinity at t equal to 0 and 0 at t not equal to 0. I cannot agree with this definition. This is, to me, a wrong definition, because how can you include something that is not defined inside something called a definition? No, you cannot do that. Okay, so this is not an actual or proper definition for impulse signal. Actually, definition for impulse signal is this thing: del of t is equal to 0. You have to assume it, imagine it. Del of t is equal to 0 for all values where t is not equal to 0. Whereas del of t is not equal to 0 at t equal to 0. You cannot say what is at t equal to 0. It is a very big amplitude. It is impulse, right? Very big amplitude. Okay. So we can move on to sketch the signal. So you just play around this definition and sketch the signal as this is the time axis. This is the amplitude axis. Right. So while sketching the signal, you have to take care of this definition. So del of t is equal to 0 for all t not equal to 0. Okay. This is t equal to 0, right? And the del of t is not equal to 0 at t equal to 0. So at t equal to 0, what you have to draw is a very big amplitude. Okay, a very big amplitude. This is an impulse signal, right? This is del of t. We cannot say what is the amplitude at t equal to 0. It is a very big amplitude. But what you can say is for all other t, the amplitude is 0. Okay, so this is how you sketch an impulse signal, right? And now the next part is to list the properties of continuous time impulse function. So some of the properties of continuous time impulse signal are: first property, I'm listing the properties. First property, integral over minus infinity to plus infinity del of t dt will give you 1. Okay, so you have to understand the implications of this statement. Integral over minus infinity infinity del of t dt equal to 1 means area under the impulse signal or impulse graph is going to be unity. Okay, so a unit impulse give you a unit area. We denote the strength as A equal to 1 for a unit impulse signal. We say it as strength of a signal usually. Okay, that is the first property. The next property is integral over minus infinity to infinity multiplication of any signal x of t into impulse signal del of t and integrate it as then we will give you x of 0. This is the next property, x of 0. Okay, and this property is sometimes called sampling property. Okay, so when you multiply a signal with del of t, you will get whatever signal being multiplied. No, it is not a signal. You have to take care that the answer is not a signal. X of 0 is never a signal. It is the amplitude, just a scalar value, constant amplitude of x of t at t equal to 0. Okay, x of 0 is the amplitude of x of t at t equal to 0. It is a constant value, scalar value. Okay. Now there is one more property. Integral over minus infinity to infinity x of t into del of t minus t0 dt is equal to x of t0. Okay, integral over minus infinity to infinity x of t into del of t minus t0 dt is x of t0. I might have done a small mistake here. This is not sampling property. This is shifting property. Shifting property. Okay, we have got one more property. Actually, third property is a consequence of the second property itself. You can refer the text. Now the fourth property is multiplication of signal x of t into a time shifted version of impulse signal will give you x of t0 into del of t minus t0. Okay, and this property is normally called sampling property. This is sampling property. This is shifting property. Okay, so these are the main properties, and we can always write one more or two more properties. Because del of minus t is equal to del of t always. This can also be listed as a property because this del of t is an even function, even signal. So del of minus t is del of t, and del of at is going to be 1 by mod a into del of t. If you want, you can consider these two also as properties. Okay, so these are the properties of impulse signal.